The discovery that broke the rules of the solar system. A photograph sits in an archive collecting digital dust. Nobody's looking at it. Nobody cares. But hidden in its pixels is a secret that will shatter everything we thought we knew about our cosmic neighborhood. A ghost. A wanderer. A world that should not exist. Something is out there. Something massive. Something that defied every prediction, every model, every carefully constructed theory about how solar systems are supposed to work. And when astronomers finally saw it, they didn't celebrate. They panicked. Because this discovery didn't just add to our knowledge, it demolished it. It forced scientists into rooms where they shouted at each other, where friendships fractured, where the very fabric of astronomical authority began to tear. One world, one tiny frozen sphere drifting in absolute darkness, and it triggered a war. This isn't a story about finding something new. This is a story about realizing we were wrong, catastrophically, fundamentally wrong, about our place in the cosmos, about what a planet even means, about whether the map we've been teaching children for generations was ever accurate at all. Welcome to the outer darkness. Welcome to the edge of everything. Welcome to the discovery that broke the rules. The year is 2003. While the world obsesses over terrestrial concerns, a small team of astronomers is hunting ghosts in the most desolate region of space humanity has ever surveyed. They're not using cutting-edge space telescopes. They're using a ground-based instrument, systematically photographing the same patches of sky over and over, looking for something, anything that moves. They're searching the trans-Neptunian zone, a realm so distant that sunlight arrives as barely a whisper, where temperatures plunge to nearly absolute zero, where worlds drift in perpetual twilight. This isn't romantic stargazing. This is data mining. Thousands of images, automated software flagging potential objects, 99.9% false alarms, asteroids, cosmic rays, digital artifacts. The tedium is crushing, but they persist because they believe something is out there, something big. The mathematics suggests it. The distribution of smaller objects hints at it. Somewhere in the frozen waste beyond Neptune, a 10th planet might be lurking, waiting to be found. Then the software misses something, a faint dot, moving, glacially slow, so slow that the algorithms dismissed it as background noise. The images sit in storage for over a year, unexamined, forgotten. The discovery of the century, hiding in plain sight, ignored by the very technology designed to find it. January 2005. An astronomer decides to manually review old datasets. Call it intuition, call it desperation, call it fate. He clicks through a sequence of 3 images from October 2003. Frame 1, frame 2, frame 3, and there it is. A pinprick of light, shifting position, barely perceptible, but unmistakable. His heart stops, his hands shake, because he recognizes what he's seeing. This isn't another small Kuiper Belt object. This is bright, exceptionally bright, which means it's either enormous or coated in something highly reflective, and it's moving at a crawl, which means it's unimaginably far away. The realization hits like a physical blow. I found a planet. Those 4 words whispered in an empty room will echo through the halls of astronomy for decades. But here's where the story turns dark. Because in science, discovery isn't just about being first to see something, it's about being first to announce it. And in the cutthroat world of planetary astronomy, rivals are watching, waiting, scanning public observation logs for hints about what others have found. The team knows they need more data before going public. They need to confirm the orbit, measure the size, rule out any possibility of error. So they observe in secret, tracking this mysterious object across the sky, gathering evidence, preparing for the announcement that will change everything. Then disaster strikes. A competing team announces the discovery of another large trans-Neptunian object, using data they accessed from public observation logs. The team realizes they've been compromised. If they wait any longer, someone else might find their ghost in the archived images. They might lose credit for the most significant solar system discovery in 75 years. They're forced to go public prematurely. July 29, 2005. The announcement breaks like a shockwave through the astronomical community. Not one, but two massive objects in the outer solar system. And the larger of the two, provisionally designated 2003 UB313, appears to be bigger than Pluto. Bigger than Pluto. The implications are immediate and terrifying. If this object is a planet, then we have 10 planets. But if it's not a planet, then what is Pluto? The ghost has a name now, though it won't be made official for over a year. Eris, named for the Greek goddess of strife and discord. The deity who, when snubbed from a wedding, tossed a golden apple inscribed for the fairest among the goddesses, igniting the chain of events that led to the Trojan War. It's a perfect name, because Eris, the world is about to start a war of its own. Here's the problem, and it's not a small one. For over 2 centuries, astronomers had been discovering planets through observation, not definition. When William Herschel found Uranus in 1781, nobody asked, but is it really a planet? It was big, it orbited the sun, case closed. Neptune, discovered in 1846 through mathematical prediction before it was ever seen, was immediately accepted as a planet. Pluto, found in 1930, was celebrated as the 9th planet despite being oddly small and having a tilted elliptical orbit. Nobody questioned it. The word planet was something everyone understood intuitively. We didn't need a formal definition because the solar system seemed to cooperate with our expectations. Eris destroyed that illusion because Eris revealed that the outer solar system isn't a neat collection of 9 worlds. It's a chaotic swarm of thousands of icy bodies ranging from tiny fragments to Pluto-sized behemoths. And if Pluto is a planet, then logically, so is Eris. And if Eris is a planet, what about the other large objects recently discovered? Makemake, Haumea, Sedna, Quaoar. Where does it end? Do we have 15 planets? 20? 50? The solar system was spiraling out of control, and astronomers were facing an existential crisis. The International Astronomical Union, the global authority on astronomical nomenclature, called an emergency session. August 2006. Prague. Over 2,000 astronomers from around the world gathered for what would become the most contentious debate in modern astronomy. The question on the table seemed simple. What is a planet? But the answer would prove anything but. 2 camps emerged, and the divide was bitter. On one side, the geophysicists. They argued that a planet should be defined by its intrinsic properties, by what it is physically. If an object is massive enough for its own gravity to pull it into a round shape, a state called hydrostatic equilibrium, then it's a planet. Simple, elegant, universal. Under this definition, Pluto remains a planet. Eris becomes a planet. Ceres, the largest asteroid, becomes a planet. Dozens of other round worlds scattered throughout the solar system become planets. The solar system explodes in size, becoming richer, more diverse, more complex. On the other side, the dynamicists. They argued that a planet's identity is tied not just to what it is, but to what it does. A true planet, they insisted, must be gravitationally dominant in its orbital zone. It must have cleared its neighborhood of other objects, either by absorbing them, ejecting them, or locking them into stable resonances. Earth is a planet because nothing else of comparable size shares its orbit. Jupiter is a planet because it's the undisputed gravitational king of its region. But Pluto? Pluto shares its orbital space with thousands of other Kuiper Belt objects. It hasn't cleared anything. It's just one member of a vast population. Under this definition, Pluto isn't a planet. It never was. The debate raged for days. Voices were raised. Accusations flew. Some argued that the dynamical definition was arbitrary, that clearing the neighborhood was too vague, too dependent on an object's location rather than its nature. Others countered that without a dynamical criterion, the word planet becomes meaningless, a label applied to hundreds of objects with no unifying characteristic. The astronomical community was tearing itself apart. Then came the vote. And here's where the controversy deepens. The conference lasted 10 days, but the final vote was held on the last day after most attendees had already left. Of the 2,500 astronomers who attended the conference, Only 424 were present to cast ballots. A tiny fraction, a vote that would redefine the solar system, decided by less than 20% of those who came to debate it. The dynamical definition won. Resolution 5A was passed. A planet, according to the International Astronomical Union, must meet three criteria. It must orbit the sun, it must be massive enough to be in hydrostatic equilibrium, and it must have cleared its neighborhood. Pluto failed the third criterion. A new category was created, dwarf planet, for objects that are round but haven't cleared their orbits. And in a follow-up vote, a resolution that would have made dwarf planets a subcategory of planets was defeated. The message was clear. Planets and dwarf planets are separate classes. Pluto was no longer a planet. The backlash was immediate and fierce. Planetary scientists called the decision unscientific, politically motivated, a betrayal of common sense. They pointed out that the definition only applies to objects orbiting the sun, ignoring the thousands of exoplanets we now know exist around other stars. They noted that even Earth, Jupiter, and Neptune haven't truly cleared their orbits. Earth shares its path with thousands of near-Earth asteroids. Jupiter's orbit is filled with Trojan asteroids. Neptune's gravity controls Pluto itself. The definition was flawed, reactive, created in haste to solve a public relations problem rather than to reflect physical reality. But the decision stood. The solar system officially had 8 planets. Pluto was reclassified, and Eris, the world that started the war, was designated a dwarf planet. The ghost that broke the rules was now an outcast, exiled to a new category, a cosmic troublemaker forever marked by the chaos it created. But what is Eris, really? Let's journey there. Let's leave behind the familiar inner solar system, pass the gas giants, cross the orbit of Neptune, and venture into the scattered disk, a region so remote, so hostile, that it makes the Kuiper Belt look cozy by comparison. This is where Eris lives. Not in the relatively stable, disc-shaped Kuiper Belt where Pluto resides, but in a wild, chaotic halo of objects with extreme elongated orbits. These are the solar system's refugees, worlds that likely formed closer to the sun, but were violently ejected by gravitational interactions with Neptune billions of years ago. Eris's orbit is a stretched ellipse that takes 557 Earth years to complete. Imagine that. 5.5 centuries to make one trip around the sun. At its closest approach, Eris comes within 38 astronomical units of the sun, roughly Pluto's average distance. But at its farthest point, it swings out to nearly 98 astronomical units, almost 15 billion kilometers, 3 times Pluto's current distance. Out there, the sun is just a bright star, providing 1/10,000th the light it gives Earth. Temperatures hover around -230 degrees Celsius. This is the realm of eternal night, and Eris's orbit isn't just elongated, it's tilted, 44 degrees to the ecliptic, the plane where the major planets orbit. This means Eris spends its centuries-long year soaring high above the solar system, then plunging far below it, like a comet on an apocalyptic scale. It's a rogue, a wanderer, a world that doesn't play by the rules. For years, astronomers believed Eris was significantly larger than Pluto. The Discovery team estimated its diameter at around 2,400 kilometers, making it the largest known dwarf planet. But in November 2010, something extraordinary happened. Eris passed directly in front of a distant star, an event called a stellar occultation. By timing how long the star's light was blocked from different locations on Earth, astronomers could measure Eris' diameter with incredible precision. The result shocked everyone. Eris measured 2,326 kilometers across, almost exactly the same size as Pluto. Slightly smaller, in fact. But here's where it gets interesting. Remember, Eris is 27% more massive than Pluto. Same size, but significantly more mass, which means Eris is much denser. The calculations revealed a density of 2.43 grams per cubic centimeter compared to Pluto's 1.85. This tells us something profound about Eris's interior structure. While Pluto is roughly 70% rock and 30% ice, Eris must be predominantly rock, perhaps 80% or more, with only a thin shell of ice coating its surface. It's a rocky world masquerading as an ice world, a wolf in frozen clothing, and that ice shell is one of the brightest surfaces in the entire solar system. Eris has an albedo of 0.96. It reflects 96% of the sunlight that reaches it. Only Saturn's moon Enceladus, with its fresh ice geysers, is brighter. Why is Eris so reflective? The leading theory is atmospheric collapse. Like Pluto, Eris has a thin atmosphere composed of nitrogen and methane that has sublimated from surface ices. But as Eris travels to the far reaches of its orbit, temperatures drop so low that this atmosphere freezes solid and falls to the ground as snow. A global snowfall, lasting decades, coating the entire world in a fresh layer of brilliant white frost. Then as Eris begins its 280-year journey back toward the sun, this frost warms, sublimating back into gas, renewing the atmosphere, only to freeze and fall again centuries later. Eris breathes on a timescale we can barely comprehend. Recent observations from the James Webb Space Telescope have added another layer of mystery. Spectroscopic analysis revealed unusual isotope ratios in the methane on Eris's surface. The distribution of deuterium, heavy hydrogen, suggests this methane wasn't just frozen from the primordial solar nebula. It may have been chemically processed, possibly by geothermal activity, which means that deep inside Eris, beneath kilometers of ice and rock, there may be, or may have been, heat. Radioactive decay from elements in its rocky core could have kept Eris' interior warm for billions of years. Warm enough for chemical reactions. Warm enough perhaps for liquid water. This frozen world at the edge of everything might have a warm heart, and Eris isn't alone. In September 2005, just weeks after the discovery was announced, astronomers using the Keck Observatory's adaptive optics system spotted something extraordinary: a moon orbiting Eris. This was the final piece of evidence that sealed Pluto's fate, because while you can estimate an object's size from its brightness, you can only determine its mass by observing its gravitational effect on another body. By tracking this moon's orbit, astronomers could apply Kepler's laws and calculate Eris's mass with precision. That's how they proved Eris was more massive than Pluto. That's how they made the planet debate unavoidable. The moon itself is fascinating. With a diameter of about 700 kilometers, it's one of the largest moons of any dwarf planet, second only to Pluto's Charon. It orbits Eris every 15.8 days in an almost perfectly circular path. But here's the strange part. While Eris is brilliantly white, its moon is dark. Incredibly dark. Darker than coal. With an albedo of only 0.04, it reflects just 4% of the light that hits it. It's one of the darkest objects in the solar system. Why the dramatic difference? The leading theory is a giant impact. Early in the solar system's history, a massive object slammed into the young Eris, blasting debris into orbit. This debris coalesced to form the moon. But the violence of the impact stripped away volatile ices, leaving behind a dark, rocky body, a scar from a cosmic catastrophe billions of years ago. The moon's name is Dysnomia. In Greek mythology, Dysnomia is the daughter of Eris, the demon spirit of lawlessness and poor civil constitution. It's a fitting name for a moon born from chaos, orbiting a world that overturned the established order of the solar system. But there's another mystery here, one that's only recently come to light. Dysnomia is tidally locked to Eris, always showing the same face to its parent world, just as our moon is locked to Earth. But here's the problem. Dysnomia's mass is far too small to have tidally locked itself to Eris in the age of the solar system. The physics don't work. Unless Eris itself is dissipating tidal energy far more efficiently than standard models predict, which suggests Eris's interior might not be a solid, frozen mass. There could be a subsurface ocean, a layer of liquid water, kept warm by radioactive decay and tidal heating, hidden beneath kilometers of ice. If true, this would make Eris one of the most geologically active worlds in the outer solar system, a frozen shell concealing a warm, possibly habitable ocean. Life in the most unlikely place imaginable. Let's be clear about what this means. Eris is currently 96 astronomical units from the Sun. That's 14.4 billion kilometers. At that distance, solar heating is negligible. Any warmth inside Eris must come from within, from the decay of radioactive elements like uranium, thorium, and potassium in its rocky core. From tidal interactions with dysnomia, from the slow release of primordial heat left over from the violence of its formation. And if there's liquid water, there's chemistry. Organic molecules could form, complex reactions could occur. Could life exist in such an environment? Almost certainly not. The conditions are too extreme, the energy too limited. But the fact that we're even asking the question about a world so distant, so cold, so utterly alien, tells us how much we still don't understand about the limits of habitability. Here's what haunts astronomers. Eris is the most massive known object in our solar system that has never been visited by a spacecraft. We've sent probes to every planet. We've orbited asteroids and comets. New Horizons gave us breathtaking, intimate views of Pluto in 2015, revealing a geologically active world with nitrogen glaciers, water ice mountains, and a complex atmosphere. But Eris remains a point of light, a handful of pixels in our best telescopes. Everything we know about it comes from indirect measurements, occultations, spectroscopy, orbital dynamics. We've never seen its surface. We don't know if it has mountains or craters or plains. We don't know if it's geologically active or dead. We don't know what secrets its moon holds. A mission to Eris would take at least 25 years, probably longer. Launch windows are unfavorable. The distance is staggering. The spacecraft would need to be robust enough to function for decades in the radiation environment of space, then transmit data back across billions of kilometers. The engineering challenges are immense. The cost would be astronomical. And yet, some scientists are advocating for exactly this, because Eris represents a class of object we've barely begun to explore. The large dwarf planets of the scattered disk, worlds that formed in the outer solar system, that preserve a record of conditions in the early solar nebula, that might tell us how planets form, how solar systems evolve, how common our cosmic architecture really is. There's a deeper question here, one that goes beyond Eris itself. The discovery that broke the rules didn't just demote Pluto. It revealed that our solar system is far stranger, far more complex than we ever imagined. For centuries, we thought we lived in a tidy system, 4 rocky planets, 4 gas giants, and Pluto. But the truth is messier. Beyond Neptune lies a vast third zone, the Kuiper Belt, the scattered disk, the detached objects. Thousands upon thousands of icy worlds, ranging from tiny fragments to planet-sized behemoths. We've discovered only a fraction of them. Current estimates suggest there could be tens of thousands of objects larger than 100 kilometers in diameter. Dozens that rival Pluto and Eris in size, maybe even something larger. In 2014, astronomers discovered hints of an object they called the Goblin, a world with an orbit so distant and elongated that it takes 40,000 years to circle the Sun. Its discovery reignited speculation about Planet 9, a hypothetical super-Earth lurking in the outer darkness, 10 times Earth's mass, hundreds of astronomical units away. If Planet 9 exists, it would be the true ghost of the solar system, a world so distant, so faint, that it's escaped detection despite decades of searching. Some models suggest it could take 10,000 to 20,000 years to complete one orbit. A world where the Sun is barely distinguishable from other stars. A planet in name, but alien beyond comprehension. Is Planet 9 real? Nobody knows. The evidence is circumstantial. Unusual clustering in the orbits of distant objects that could be explained by the gravitational influence of an unseen massive body, or could be statistical noise. The search continues. Surveys like the Vera C. Rubin Observatory's Legacy Survey of Space and Time will photograph the entire visible sky every few nights, creating a time-lapse movie of the cosmos. If Planet 9 exists, if there's a super-Earth hiding in the outer darkness, we'll find it within the next decade. But here's what keeps astronomers awake at night. What if there's more than one? What if the outer solar system is populated by several planet-sized worlds, all on extreme orbits, all too faint and distant to detect with current technology? What if our solar system isn't defined by 8 planets, but by 8 planets and a swarm of planet mass objects in the outer darkness? The implications are staggering. Because if our solar system has hidden planets, then other solar systems probably do too. And if planet formation regularly produces these distant, scattered worlds, then the exoplanet surveys we've conducted, which focus on planets close to their stars, are missing entire populations. Zoom out. Let's think about what Eris really represents. Not just a dwarf planet, not just the world that demoted Pluto, but a symbol of how fragile our understanding of the cosmos really is. We thought we had the solar system figured out. We'd been teaching the same model for 75 years. 9 planets. Simple, stable, complete. Then one discovery, one faint dot in archived images, revealed that we were wrong. Not slightly wrong, fundamentally wrong. The solar system wasn't complete, it was barely explored. This is the pattern of scientific progress. We build models. We refine them. We teach them as fact. And then nature reveals something that doesn't fit, and the models crumble. Eris did that to planetary science. It forced astronomers to confront uncomfortable questions. What is a planet? Why does the definition matter? Who gets to decide? And in forcing those questions, it made the solar system more interesting. Because the answer isn't simple. The universe doesn't care about our categories. Planets, dwarf planets, asteroids, comets. These are human labels, imposed on a continuum of objects that form through the same processes, from the same materials, governed by the same physics. Nature doesn't draw sharp lines, we do. And every time we discover something that blurs those lines, we learn something profound. Eris taught us humility. It taught us that the map is not the territory, that our models are approximations, useful fictions that help us organize knowledge but should never be mistaken for truth. It taught us that the solar system is not a museum, a static collection of objects to be cataloged and filed away. It's a dynamic, evolving system, still revealing its secrets, still surprising us. And Eris is still out there. Right now, as you watch this, it's drifting through the outer darkness. 96 astronomical units from the sun, slowly climbing toward its aphelion. Its surface is coated in methane frost, glittering in the faint starlight. Its moon, Dysnomia, traces its eternal circle, locked in a gravitational embrace. Deep inside, radioactive decay warms its rocky core, perhaps sustaining a hidden ocean, a pocket of liquid water in the frozen void. It's a world we've never seen up close, a world we may not visit for decades, if ever, a world that changed everything by simply existing. The astronomer who discovered Eris calls himself the Pluto killer, but that's not his legacy. His legacy is revealing the truth, that Pluto was never alone, that the outer solar system is teeming with worlds, that our cosmic neighborhood is larger, stranger, and more wonderful than we ever imagined. Eris didn't kill Pluto. It freed Pluto, freed it from the burden of being an oddball, the misfit 9th planet that never quite fit the pattern. Now Pluto is recognized for what it truly is, the king of the Kuiper Belt, the largest and most famous member of a vast population of icy worlds. And Eris? Eris is the queen of the scattered disk, the most massive of the outcasts, the world that forced us to redraw our maps. There's a photograph, taken in October 2003, a faint dot barely visible against the background stars. For over a year, nobody looked at it. Nobody cared. It was just another image in a vast archive, one of thousands, unremarkable and forgotten. But hidden in that photograph was a truth that would shatter our understanding of the solar system. A ghost, a wanderer, a world that should not exist. And when we finally saw it, everything changed. That's the power of discovery. Not to confirm what we already believe, but to overturn it, to reveal that the universe is stranger, more complex, more beautiful than our theories predict. Eris did that. One world, one tiny frozen sphere at the edge of everything, and it broke all the rules. So here's the question we're left with. What else is out there? What other ghosts are lurking in the archived images, waiting to be found? What other worlds are drifting in the outer darkness, too faint, too distant, too patient to reveal themselves? The solar system we know, 8 planets, 5 recognized dwarf planets, thousands of smaller objects. Is this the complete picture? Or are we still in the prologue, still mapping the edges, still discovering that everything we thought we knew was just the beginning? The universe doesn't give us answers. It gives us mysteries. And Eris, the world that broke the rules, is one of the greatest mysteries of all. A frozen enigma, wrapped in methane snow, hiding secrets we can barely imagine. A world that taught us that the most important discoveries aren't the ones that fit neatly into our models. They're the ones that shatter them, the ones that force us to question everything, the ones that remind us that no matter how much we learn, the cosmos will always be one step ahead, waiting to surprise us. And somewhere out there, in the frozen darkness beyond Neptune, beyond Pluto, beyond the edge of everything we know, Eris continues its lonely orbit, a goddess of discord, a harbinger of chaos. A world that changed everything by refusing to fit the rules we made. The question is, are you ready for what we find next? If this journey to the edge of the solar system left you in awe, if it made you question everything you thought you knew about our cosmic home, then subscribe. Because the universe is full of secrets, and we're just beginning to uncover them. Comment below. Do you think Pluto should still be a planet, or did Eris reveal a truth we needed to face? Share this with someone who still believes the solar system has 9 planets. It's time they met the world that broke all the rules. And remember, the most terrifying and beautiful thing about space isn't what we've discovered. It's what's still out there, waiting in the darkness, ready to shatter everything we think we know. The cosmos is vast. The mysteries are endless. And the next discovery could change everything. Again.